This video is going to be over the Mayneord F factor as well as equivalent squares. So I want to give you a few problems here that I will work through for each scenario. That way you can kind of follow along and see what I'm talking about. The Mayneord's F factor, if you look through, and let me make sure we've got a summary here of several different formulas, and I want to make sure that you know where to find that. If you go here under the chapter 9 material, you can see a number of options here, one of which is the chapter 9 important formulas. So we're going to choose that. It takes a little while to load up here. And the two formulas here that we're going to focus on, actually three, if you really think about it, it's going to be these two for the equivalent square. And then for the Mayneord's F factor, it's going to be this formula right here. So what I'm going to do right now is I'm going to go over here on this side of the screen, and I'm going to kind of write down, since I get the annotate function going, that be a good thing to do. So I'm going to put down F for the Mayneord F factor is going to be equal to the SSD that we're moving to, plus the D max for the energy, divided by the original SSD plus the D max for the energy. I'm going to square that. And then over here, we're going to have a couple other terms. We're going to have the original SSD F1 plus whatever distance we are evaluating the dose at, divided by the new SSD plus D, and all of that is going to be squared. So we're looking at adding these terms and then these terms and then squaring the result. You can also look, there are other ways to do this depending on what calculator you have. And then there's this divided by this, and it's going to be squared. So we'll get into how to type that kind of stuff into the calculator here in just a little bit. So what we're going to do now, let's see, I have to discontinue this, but it should keep as I go to the problem here. Now, the problems that we have in this particular quiz are going to come from this particular homework assignment. What you're going to have here, you're going to have several different problems that you're going to have to work through in order to be able to do this. And each problem is going to be different from the last. I have figured out how to enter this in with variables and to pick exactly what the range needs to be in order for you to be able to work these problems. So that's where this is coming from. Now, one particular iteration here is going to be this problem. And the question in this particular case is that if we have a PDD of 69% with an SSD of 100 centimeters, it's going to be where we start. What is the Mayneord F factor with an SSD of 80 centimeters? So it's going to be moving from here down to here. Now the treatment depth is going to be 7 cm and the Dmax is going to be 1.5. So let's kind of write down and identify exactly what these variables mean, how they're identified, that kind of thing. The original SSD that we have is going to be 100. The SSD that we're moving it to is going to be 80. Now, one thing that I want you to bear in mind as you are working these particular problems is that if we are moving from an SSD that is this big to one that is smaller, the Mayneord F factor should be less than 1. If, however, we end up moving from here to a bigger SSD, this will be greater than 1. So I want you to keep that in mind as you work the problems. The distance that we are going to be evaluating here is at 7 centimeters. And the D max is going to end up being 1.5 cm. This is for a 6x beam, so that's about where D max is going to end up. So let's go through and let's do the calculation here. So F2 in this particular case is going to be 80. plus D max in this particular case, or DM, depending on how you want to write it, is going to be 1.5. So we're going to put that in just like that. And then on the bottom here, we've got F1, which is going to be 100. That's where we started out. Plus D max, which is 1.5. All of that's going to be squared. This is going to be multiplied by F1, which is going to be 100. Plus, and then the distance, which is 7. And then on the bottom, we're going to have what it's moving to, which is 80, and we're going to add 7 to that. And so here we're going to end up on top. If you add 1.5 to 80, you end up with 81.5. On the bottom, you've got 100 plus 1.5, so that'll be 101.5. All of that'll be squared. Over here, you're going to have 107. And on the bottom, you're going to have 87. So your F Maynard factor is going to be 81.5 divided by 101.5. That quantity is squared times 107 over 87, and that's going to be squared. So another way to look at this is you can divide what this is and then square it. Or another method that you can do is to take that squared over this squared times this squared over this squared. And the reason this method kind of appeals to me is you can type it in on any basic calculator, you can come up with what it is. 81.5 squared, let me look that up because I'm not a math whiz. I do not remember what that turns out to be, but 81.5 squared is 6,642.25. That's a big number, so. But it's exact. Oops, that should be 0.25. On the bottom, the 101.5 squared, let's try that. All I'm doing is typing this into my iPhone calculator. Let's see, 10,302.25. And that'll be multiplied by 107 squared. It turns out to be 11,449. And then on the bottom, 87 squared is 7,569. So if you go through and if you multiply all of that out, what do you get? Other than one just big long mess, 10,302.25 multiplied by 11,449 divided by 7,569. And I come up with the same answer that we get here. Okay, so just remember to square those numbers as you go through. And I'm going to put on eraser and let's go through and let's work another one here. I think I nuked all of it there. Okay. Oh. I'm going to get rid of this one and I'm going to start another. Okay, let's I want to prove a point here, so let's try another one here. Okay. My. You'll see why I'm doing this here in just a minute. There we go. The reason I chose this one is for an SSD that's greater than what we started out here, because I want to show you that the Mayneord F factor should end up being over 1. So now let's go back to the drawing board. Let's see. So F sub 1 is where we started out. For this particular exercise, I just left it at 100, so that will not vary. We're going to change it to 110. The distance that we were looking at is going to be 6 cm. The max is going to be 1.5. So the Mayneord F factor in this particular case is going to be 110 plus 1.5. And then 100 plus 1.5, all of that gets squared, multiplied by 100 plus 6, and then 80 plus 6. So that ends up equaling a 110 plus 1.5 is 111.5. On the bottom is 101.5. All of that gets squared, multiplied by 106 over 86 squared. So F is going to end up being 111.5 squared over, if I get that drawn, I have a hard time with the stylus sometimes. 101.5 coming at you live, 101.5 squared. All right, let's try 106 squared over 86 squared. And the numbers turn out to be, and I'm going to have to do the multiplication here. 111.5 times 111.5. And that gives me 12,432. And if I could just don't, okay, hang on a second. I have some technical difficulties here. No, I really just want the eraser. There we go. 0.25. There we go. Over 101.5. So 10302.25, which probably sounds a little familiar because it came out from the last problem. Multiplied by 106 squared. Okay. 11,236. And then on the bottom there, it should be 86 squared. 7396. And if you go through and if you do the multiplication here and division, it's 12,432.25 divided by 10,302.25 times 11,236 divided by 7396. I don't think I typed something in right. Let's see, 432.25 times 11,236 divided by 7396. I think I messed up somewhere. And let's try this again. 111.5 times 111.5. Okay. So that looks right. Okay, 10,302. Okay, that looks good. 106. Let's make sure I added all of that together, yeah, times 106. Then 236. 86 times 86, 7396. Okay. All right. So let's see. 12,432.25 divided by 10, 302.25 times 11, 236 divided by 7396. I am not coming up with the answer that is there. Oh, you know why? I know why. I don't know what that 80 was doing there, but it shouldn't have been there. See, when you pay attention, things work a lot better. Let's see. Let's try 110 plus 6. So that should be 106 over 116. Hey, look at me. I can do math. Okay, 116 for that. And that number ain't no good. So let's try. 13,456. Okay. So now let's work through this again, shall we? Okay. Okay, times 11, 236 divided by 13, 456. Aha. Aha. There we go. We got 1.00 and it says 765. So I'm going to round that to 1.008. Okay. So that's that part of it. Now, another part of it that I want you to be able to do, and let me clear out here all of this stuff. Okay, now, not only do I want you to be able to do the Mayneord F factor, but I want you to use the Mayneord F factor in order to be able to produce the PDD at a particular at that particular depth. So that's what problem 1, 2, 3 is just finding the Mayneord F factor. 4, 5, and 6 are for finding the new PDD. So basically in 4, 5, and 6, what you're going to be doing, and you can run these homework assignments as many times as you need to in order to be able to not only improve your score, but to be able to understand the concept a little bit better. So here, if we have a PDD of 64 with an SSD of 100 cm, so what's the new PDD at an SSD of 120? And the treatment depth is 5 cm and the Dmax is 1.5. So again, a lot of the process here is going to be pretty much the same. Let's go to annotate. So again, it's always good to identify your variables. Let's see, so F sub 1 is going to be 100, F sub 2 is going to be 120, your depth is going to be 5, and the Dmax is going to be 1.5. So we're going to go through and we're going to find the F Mayneord factor, or I'm going to write it all out. Well, I guess we'll need to find it too. So F sub 2, this is going to be 120 plus Dmax, which is 1.5. divided by 100 plus 1.5, well, that's squared, times, and let's see, it's SO1, so it's 100 plus 5, and then 120 plus 5, and all of that is going to be squared. Okay. So what do we end up with here? We got 121.5, 101.5, all of that squared. I'm going to go ahead and work this out on the calculator. You guys can multiply these numbers out, I'm sure. Okay, now I come up with an F Maynard factor of 1.01106, blah, 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 blah. So I'm going to keep the exact number, but if I were to ask for the Maynard factor, it would be out to 3 decimal places. Now, that's not the only thing that we need here, though. If we are looking to produce what the new PDD is, basically we're going to take the F Maynard factor and we're going to multiply it by the old one, or the one that's given. And in this particular case, I'm going to take 1.011 and I'm going to multiply this by 64. And when I do that, I come up with 64.7. The point of this is to show that as you move the SSD away from the source, your percent depth doses will increase. So we've gone from 64 here to 64.7. Had we moved from an SSD of 100 to say 80 or something like that, this would have decreased. So that's one of the main points here that I want you to see out of this particular problem set. Now that all of that is done, let's take a look, and I'm going to cancel any changes to this. Let's take a look here at the equivalent square. The equivalent square, we'll just take a look at the problems here. They're all pretty much the same. And we're going to focus in. I know that you can do this with a circular field, but right now we're going to focus in on the rectangular field. For some reason, as I was typing this in, the formula didn't like the value of pi. So that was getting hard to be able to do circular fields for some reason. So what I'm going to do is I'm going to be giving you rectangular fields of these measurements out to 2 decimal places. You're going to give me the equivalent squared field, or the length of one side of that field, here out to 1 decimal place. So the question is, how do you go about starting a problem like this? So if I give you this and I'm asking you for the side of one of the sides of the equivalent square, what we're going to do is we're going to take this formula, A over P. Where does it come from? This, go over here. It's going to come from here. It's going to be this. We're also going to use this. And the reason is that if you replace A with B or B with A, in this particular case, if you replace B with A, it's going to reduce down to this particular formula. So these are basically the same thing. It's just this is a reduced form of this whenever A is equal to B. So we're going to go back, where did I put it? Right here. So we're going to go back here. We're going to bring up the annotation. And we're going to say here that we're going to have A times B over 2. And I should, how about I put a big dot there? Okay, A plus B. Sorry for the bad penmanship here, but that's how it goes. So let's see, do I have all of this in here? I want to make sure that I got this right. Let's see. A times A2. Yep, I got it. Okay. All right, so now let's start this up. So in this particular case, we're going to have 16.71 times 18.5 16.62 all divided by 2 times 16.71 plus 18.62. And if we go through and we multiply all that out, what do we come up with? Well, the top part here is going to be 16.71, which I'm going to type out here on the calculator. 16.71 multiplied by 18.62. And that ends up giving us 311.1402. On the bottom, if I take 16.71 and add 18.62 and multiply that by 2, I get a result of 70.66. When I take this result, add it together and multiply by 2, that's where it comes from. So the results here, that ratio ends up becoming 4.4033. Now, question is, what do I do with that? Well, remember that other formula that we had? Length of the side divided by 4. I've got this ratio, figured it out right here. All I have to do is solve for A to figure out the length of the side. So if I take 4 and multiply it by that ratio, basically I'm going to take the answer here and multiply it by 4. And again, I come up with 17.6. Units are cm. Make sure to enter those in there. If you don't, that's going to be bad. And that's where that comes from. This method will work for any field sizes that we're going to have. And I'm going to have you practice from generally about 5 times 5 to 20 by 20s, anywhere in between. So that's what I really wanted to show you out of these two homeworks. And I'll have other videos coming out on other computations that we're going to have to do later on. So hope that helps.